I hope that my slide is visible to all of you.
Yes, sir. Good morning.
Yes, sir.
Morning. Okay. So on the last turn, we started with the unit number 1, and it is about the measurement of resistance. And then we talked about the classification, low resistance, medium resistance, and high resistance. And medium resistance is the normal and moderate range, and it is, from measurement point of view, it is having minimum challenges. And most of the method that you people are aware of, it is basically used for measurement of medium resistance. And the low and high resistance measurement are having different challenges. And medium range resistance measurement methods, if applied to measure low and high resistance, because they won't be able to cater the issues related to the low and high resistance measurement, so they won't fetch you the good results, means accuracy will not be there. So different sets of methods are required to measure low and high resistances. uh, Means that we'll first discuss, when we'll discuss low and high resistance, first we'll discuss the issues, and then we'll discuss the method, how these methods are used to means to tackle, address the issues in these resistance measurement, and then they give us accurate result. So as far as medium resistance measurement methods are concerned, we'd already I listed here on the last turn. We discussed about, means I told you that ammeter voltmeter method, substitution method, Wheatstone bridge method, and ohm meter methods. And I'd put it in serial according to their complexity. So the most simple method is ammeter voltmeter method, and I think most of you must be aware of it. And then we started our discussion on voltmeter ammeter method. So voltmeter ammeter method, as you know, that we this is a circuit for voltmeter ammeter method, and we take the reading of voltmeter and ammeter and take the ratio according to the Ohm's law. The ratio will be equal to the resistance. But because of the circuit configuration, this measured value of resistance is not equal to the true value of the resistance, and that's what we discussed here. And your measured value in this case is always more than the true value. And this deviation, we are able to have a formula for that, this relative error, that is ammeter resistance divided by the unknown. And similarly, this in this case, major issue is the voltage drop across the ammeter, and this voltage drop is counted here in the voltmeter. So this imperfection can be taken, this particular issue is cause of error in this method, in this circuit, you can say. And to take care of this issue, what we can do, we can put voltmeter across the resistance, and then that will, so this will solve the issue which we are having in this circuit. So the resultant circuit will be this. Here what we are doing, we are putting voltmeter across the resistance and ammeter before that. So whatever issue this method was having, it is not present here, but it is having another issue. Now the ammeter reading is having problem. As I told you at the starting, that this method will give us good accurate result only in the case your voltmeter should give the reading, the voltage across the resistance, and ammeter should give the reading current through the unknown resistance. So here in this case, we are getting satisfied one of the requirement, that is voltmeter is giving reading voltage across the unknown resistance, but ammeter is not able to give the current through the resistance. Now in this case, ammeter reading will include the current through the unknown resistance as well as current through the voltmeter, and this will lead to the error. And then we analyzed circuit and expressions in all. So in this case, we are able to find that the measured value of the resistance is less than the true value, unlike your previous circuit configuration. And the relative error we found ultimately is this, that your unknown resistance divided by the voltmeter resistance. And then we concluded, means both of them are imperfect, and still, with the help of all these analysis and the final result, if we are aware of all these results, means analysis, then we made a conclusion that the previous circuit is good, will give you the better result, give you less relative error if your unknown resistance is at the higher side within the medium resistance range. And obviously, because here in error expression, your unknown resistance is coming in the denominator. Similarly, in this case, if you look upon the expression, you'll find that unknown resistance is coming in the numerator. So if unknown resistance value is less, then relative error will be less. So this particular circuit of the ammeter voltmeter method is good when your unknown resistance is at the lower side. So this conclusion has been made. Now on the last turn, yes, if anybody is having any query regarding these things which I tried to summarize and we had already discussed on the last turn. So I recapitulated everything that we discussed on the last turn. So if you are having any query regarding all these things, whatever I discussed, means I summarized today and discussed on the last turn, you can ask please. Any query, any doubt you are having, you can ask please. Ji, am I audible to all of you?
Yes, sir.
So if anybody is having any query regarding whatever we discussed on the last turn, you can ask please. Okay, then I'll ask one question that I asked. In a method, and both of them are contemporary, but one gives the good result for higher value of the resistances and other gives the good result for lower value of the resistances within the medium range resistance limit. Then where is the boundary? How will you draw the boundary? What is the criteria?
So can we take the mean of RA and RV?
Mean of
RA and RV.
RA and RV. Then what
Yes.
will happen if we'll
So
take the mean?
so the
I'm
well.
talking about the range. है ना? Range means unknown resistance
Yes,
has
sir.
nothing to do with
Yes,
the
sir.
RA and RV. जी
That's why
बताइए.
I'm telling सर जो सर एमीटर वाले केस में सर जो हायर वैल्यू साइड होनी चाहिए तो सर वो RA प्लस RV बाई 2 एंड बिटवीन द RV के बीच में हो जाएगी सर वो एक रेंज ये हो जाएगी एक केस के लिए दूसरे केस के लिए RA से
नहीं
लेके
देखो रेंज तो हमारी ये है. देखो ये रेंज है मीडियम रेजिस्टेंस की 1 to 100 kilo ohm. So what I'm saying that the first circuit is good for higher side. This is the range actually. For higher side, means if your resistance, obviously because your unknown resistance is in denominator, error expression, it is coming in the denominator. So obviously when your unknown resistance is high, so your relative error will be less. So if you are saying that we should take the middle point of this range, then it is having some logic. But if you're taking the voltmeter resistance and ammeter resistance and then taking the range, means mean of it, it is not having any logic, because that ammeter and voltmeter reading, resistances are not defining your range. They are defining the error only. You understanding what I'm saying?
yes sir got it.
So now I'm asking, where will you put what logic will you use to draw the boundary. It is only matter of common sense. Electrical engineering is not required here. Anybody, whoever is present today? Acha, if we are starting, suppose we are using both the methods, है ना? I'm helping you. We are using both the methods, and we are starting from 1 ohm, and we are going, and every value we are taking, and we are incrementing it by 1 ohm, 2 ohm, 3 ohm,
Sir, I
4
got
ohm,
it.
and then you got it, na?
Yes,
So
sir.
what
So
is this?
when
What is the
so when
answer?
the error of both the side will be equal.
Yes, that's correct. That's correct. That's what I want to know. Obviously, that will be the boundary point. And before that, one of the method will give you less result, less error, and other will give you more. And above that, then another method will give you less error, and at that point you will have, means boundary line is the value of the resistance where both the methods are giving same result, same error. So that's what I've done here. The division point between two methods is when the errors are equal. You see, errors are equal. So this is from this formula we can find out the boundary point, depending, and obviously it depends upon the value of the value of your ammeter resistance and your voltmeter resistance. So this is fine to all of you. जी हाँ हाँ नहीं तो बोल दिया करिए भाई.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now we'll solve one problem. This is a very good problem. Although solution is always important, but many concepts we have used here, and some of the concepts we used here you learn in your previous course also. So I hope that you still remember it, and it will get revised also. So you go through it, you read it. A resistance of approximate value of 80 ohm. Somebody was asking that how should we know that it is, because we are in the process of measuring unknown resistance. So how can you say that it is having higher value or lower value? But many times you will find their approximate values are known. Even I'll tell you, this is also possible. Your ohm meters are not very accurate kind of devices, means instrument. So you can use ohm meters also to find out the, because accurate measurement is one of the challenge always. And if we are going for accurate measurements, and we take care of, means we can make all the calculation, everything we can do. So in this case, you see in this problem, it is given approximate value is 80 ohm, although it will be near about 80 ohm. It won't be exactly 80. So now you're having an idea that in what range your unknown resistance is. So anyway, it's to be measured by ammeter voltmeter method using 1 ampere ammeter having a resistance of 2 ohm, and 50 voltmeter having a resistance of 5000 ohm. Suggest which one of the two circuit method ki jagah circuit that in voltmeter meter method should be used. Now I want that you should give the answer.
Sir, please repeat the question.
It is written here. You read it. A part I am asking.
Sir, but in the
Sir,
question, sir,
voltmeter
it
method will be
is
used.
voltmeter ammeter method is mentioned. Sir, you are asking whether it is voltmeter or ammeter method.
No, voltmeter, this problem is related to voltmeter meter method only, and there are two circuits, है ना?
So the
Two
second circuit will be
possible
used.
second circuit will be used.
Yes, sir.
Means, what is the boundary resistance? This circuit. What is the boundary resistance? Whoever is telling
100,
this
sir.
is 100.
100.
So it is less than
100 ohms.
that's correct. That's correct. So approximate value is less than 100. So we'll go for the second circuit. That's correct. Now in the B part, supposing in the suggested method, the following measurements are made. Current is, these are the voltmeter and ammeter method. Means when you are using suggested method and your suggested method is this. So now voltmeter ammeter reading is given here. That I is equal to 0.42 ampere and voltmeter reading is 35.5 volt. What is the resulting error with the accuracy of the instrument is plus minus 0.5% at full scale. Now I'll discuss few things here. You try to listen carefully. Although many things that I'm going to discuss here, you may have you had already studied in your previous course. Here we are talking about the error in the method. Means all these things we discuss, this is error of the method. Now we are using instruments. These instruments are also having an error, and that is specified here. That is plus minus 0.5%. Your voltmeter and ammeter method is your voltmeter ammeter method. Your voltmeter and ammeter that you are using, they are also having an error of plus minus 0.5% of the full scale. Now I'm asking one thing you must have studied earlier. Error is given as a, for the instruments, error is given as a plus minus 0.5% of full scale and plus minus 0.5% of true value. So what is the meaning of these two representations, you can say? You understanding what I'm saying? You must have studied earlier.
Yes, sir.
So if suppose it is mentioned as plus minus 0.5%, very difficult to write here with the mouse, especially with the 0.5% of true value. True value. What is the difference? जी ये आप पढ़ चुके हैं पहले.
सर 0.5%
What is the
इन केस ऑफ फुल स्केल की रीडिंग में सर, जो भी सर मीजरिंग इंस्ट्रूमेंट होगा उसकी फुल स्केल रीडिंग के रेस्पेक्ट में 0.5%, मतलब कि एरर सर कांस्टेंट रहेगा वो, व्हाट एवर द वैल्यू विल मेजर.
correct
एंड सर
correct correct correct. इस केस में ट्रू वैल्यू में क्या होगा?
सर ट्रू वैल्यू के केस में सर जो भी एरर होगा सर वो वैल्यू डिपेंडेंट होगा सर, व्हाट एवर द ट्रू वैल्यू देयर विल डिपेंड ऑन दैट.
It means whatever value you are
मतलब
measuring,
एक्चुअली
it will be 0.5% of that value. So which out of these two, means suppose you are purchasing a meter, and a man means shopkeeper is offering 2 meters, and one is shopkeeper is saying that it is plus minus 5% of the full scale, another is plus minus 5% of true value. Which out of these two you will consider more accurate?
सर ट्रू वैल्यू आई गेस.
True value, not guess. True
Yes, sir.
value will be
So actually
obviously
because
your error will increase if you are measuring less than full scale in when this error is means error is indicated as a full scale, because when you are at the full scale, then your error is 0.5%. And suppose I'm taking the meter, your meter, your voltmeter whose range is 50 volt. When you are measuring 50 volt, then your error is 0.5%, plus minus 0.5%. Now when you will you are measuring suppose 25 volt, then your error will increase. Because your denominator will be less. Means if you calculate 0.5% of 50 volt, 0.5% of 50 volt, कितना होगा 0.5%?
25, 25.
2.5.
क्या 25? 2.5
2.5.
volts.
हाँ, yes sir, percent 25.2 point.
ठीक है ना, 2.5 वोल्ट. तो अगर हम 25 वोल्ट मेजर कर रहे हैं तो ये 1% हो जाएगा 25 वोल्ट का, क्योंकि आपकी एरर तो सेम रहेगी 2.5 वोल्ट. कोई भी रीडिंग ले आपकी एरर 2.5 वोल्ट होगी. तो जब 25 आप यूज कर 25 वोल्ट मेजर कर रहे हैं तो उस रीडिंग में भी आपकी एरर जो होगी वो 2.5 वोल्ट होगी. वेयर एज इन दिस केस at the full scale it is 2.5 volt, but at the half scale or 25 volt it will be 1.25 volt, because it is the 0.5% of the true value. Anyway, these things I'll discuss in solving this problem. So I just discussed it at the onset, just so to revise, so that you can have a kind. But I'm using these things. You'll realize these things when I'll make the calculations in this problem. So now the first part that I told you, that somebody told me that we'll use, this is 100 ohm. So obviously this circuit will be used that I'm using here. And now the measured value, we just took the reading of ratio of these two, and then we got this value. Now using the formula, this is the advantage of analysis, whatever circuit analysis we have done, and you know that this reading is having error. And here in this problem, it is because of the two reasons that has been specified in the problem itself. One because of the methods, and other because of the error in the voltmeter and ammeter we are using. This is fine to all of you?
Yes, sir.
Okay, so we removed the error due to the method using this formula. This formula, this is the true value, this is the measured value, and this is the this is the voltmeter resistance. This formula I'm referring, this formula we have used over there, and then we got rid of method related error, and this is giving you 86 ohm. Now because of now that part which I tried to discuss, that part is here. So in this case, meters are also having error. So we should find out how much error is there because of the meter. So error in ammeter reading, it's 0.5% of full scale, that is 1 ampere. So it is coming out to be 0.005 ampere. Now this error is present when we are measuring 1 ampere, and this error is present when we are measuring 0.42 ampere. Now when we are measuring 0.42 ampere, then the percentage error is not 0.5%. You see it is 1.19%. You are able to understand there is a catch. Although and if it would have been the true value 0.5%, so at 0.42 ampere also the error would have been 0.5% only. But now you can see when error is indicated as a percentage of the full scale, when you will take the lower reading, then this percentage will increase, although your absolute error will remain same, but your percentage will. So you're understanding what I'm trying to make you understand? हाँ, बताइए.
Yes sir, yes
Yes,
sir.
sir. Error increase.
Yes, sir.
बात समझ में आ गई ना? तो अभी अगर आप मार्केट में कोई मीटर लेने जाएंगे और अगर वो ट्रू वैल्यू का मीटर आपको देगा, लाइक इन दिस सिचुएशन, if the shopkeeper is giving you 0.5% of the true value and 0.5% of the full scale, Obviously 0.5% of true value is more accurate meter, and the cost will also be very high. I'm telling you, there will be huge difference in cost when you will compare. So this is what is the meaning of these two kind of indication of the error. So accuracy, rather, you can say. Similarly, you see, we found the voltmeter reading. So 0.25 volt will be there in all the cases. And obviously, when you are measuring 35.5 volt, so it will be, error is not 0.5%, it is more than that. So this is how this means the meaning of this. Now you must have studied that if your voltmeter reading is having error, and your ammeter reading is also having error, so what will be error in the resistance, where the resistance is equal to the ratio of voltmeter reading and ammeter reading. So this is the formula that you must have studied in your previous class. This leads to the ammeter, because of the limiting error, relative error in the voltmeter reading and ammeter reading. So the error in the resistance will be this one, the addition of these two. This is the worst case scenario. So finally we'll write that absolute error due to the ammeter and voltmeter reading. This is a percentage error, obviously. So we calculated the absolute error, and this is coming out to be 1.629. Then finally we are able to give your measured value will come within this range. This kind of disclaimer, this is the way we mention that as per the accuracy of the equipments and methods, this method with this much inaccuracy in voltmeter ammeter will ensure that your reading will come within this range. If this is the true value, then it will come within this range. So this is how calculation is done, and what is the meaning of different kind of error. And then ultimately, how did we get rid of this error due to the method? All these things we discuss in this problem. So if apart from solution, if you are having any doubt, anything which you are not able to understand in this numerical problem, you can ask, please. जी पूछ लीजिए इसको.
सर मेजर्ड वैल्यू पे क्यों नहीं चलते सर? हमें उसका एरर निकाल रहे हैं, लेकिन सर हम फिर एक्चुअल रेजिस्टेंस का भी तो वैल्यू निकालते हैं उससे. मेजर्ड वैल्यू तो काफी है.
क्या
सर मेजर्ड वैल्यू जो निकलता है सर, उसके बाद
जी
हम ट्रू वैल्यू ऑफ रेजिस्टेंस निकाल रहे हैं. तो सर उसका जरूरत है सर कि कितना डिफरेंस आ ही जाएगा आंसर में? सिर्फ 2 ओम का या फिर 1 ओम का डिफरेंस आएगा?
देखो, accuracy is always a relative term. I'll make you understand. Like if you are measuring your weight, है ना, तो अगर उसमें 100 ग्राम ज्यादा हो जाए या 100 ग्राम कम हो जाए तो उससे कोई फर्क नहीं पड़ता. बात समझ में आ रही?
यस सर.
और अगर आप गोल्ड मेजर कर रहे हैं, then 0.5 gram will also matter.
Yes sir.
है ना? This is all relative. So it
Okay.
depends how much accuracy you need in your measurement. And one thing I would like to tell you, in standard practice in scientific measurement, plus minus 1% error is acceptable in general. Below that, sometime you may require in certain research work or in certain measurement where the parameters are very critical, then we require, like I'm telling you one example. Like if you are measuring the temperature of a room, means where you are sitting, and if there is an error of suppose 1 or 2 degree or up to 5 degree or 3 degree, that is not going to affect anyway. You won't feel like that, है ना? अगर जो है 25 से 28 हो गया, और लेकिन if you are controlling the temperature of certain chemical reaction,
that
and
will
where
affect.
small change in temperature will affect the outcome. So you require very accurate kind of measurement, and over there plus minus 1% even not solve the purpose. You need more accuracy. So accuracy and all these things are always relative, and accordingly you should analyze your system, and accordingly you should find out whether your system which you are considering to use for the measurement, it is catering your accuracy requirement or not.
ये सर
And
यही
that's
सर
why what
सर इससे एक रिलेटेड और क्वेश्चन था सर। पिछले साल हम सर यही
बोलिए।
मेजरमेंट, इलेक्ट्रिकल मेजरमेंट वाले क्लास में सर ने यही बात की थी। मतलब सर थोड़ा मैं ना शायद उस टाइम अटेंटिव नहीं था सर। मतलब सर जब सर मरकरी थर्मोमीटर बेटर टेम्परेचर मेजरमेंट देता है सर, तो फिर सर हम डिजिटल थर्मोमीटर क्यों यूज करते हैं?
देखो, ये डिजिटल थर्मोमीटर, the main advantage of digital domain, not only thermometer. Digital basically, process is not digital, है ना? The sensor which we are using, it is not digital. It is only the interface which is digital. You understanding what I'm saying?
यस सर, यस सर।
So digital instruments are easy to use. Even a small child will be able to read the reading. And
हाँ ये
your
सर,
analog instrument is having its own complexity as
यस
far as
सर।
interface is concerned. And how accurate is your particular thermometer with another thermometer, it is altogether a different story. It is not necessary that whatever digital instrument you are using, it is accurate. Many times you will find they are not that much accurate.
यस सर।
Or your how accurate is your thermometer, mercury thermometer. When you will go through the data sheet of both the instrument, then you will find which one is more accurate than in comparison to each other. So that you have never gone through actually. And that's why you are making the statement only hypothetically, that
यस
mercury is more accurate than digital. You first go through their data sheet, and only then you will be able to give the statement which out of these two. From the user
सर,
point
which
of
is
view,
accurate? Which is
your
accurate if
this,
I'm taking an analog emitter or analog or digital emitter, sir? So then which is more accurate, sir?
you cannot say like this. Again, I'm telling you, you have to go through it is not technology based. It is all depends upon how, means these two meters are made, and then what is the accuracy your manufacturer is claiming. Your digital instrument may be plus minus 2%, and your analog instrument may be plus minus 1%. In another set, it may be your analog is more accurate than your digital one. You understanding what I'm trying to say?
Yes, sir. Yes, sir. I understand, sir. Sir, but when we
So,
measure digital,
as
when
far
we
as
use sir,
if you compare an analog meter with the digital meter, then it is having an advantage. Digital meter is having an advantage that it is easy to use. No technical expertise is required to read the reading, and then observational, there is a less chance of observational error that you must have studied in your previous class.
yes, sir. Yes, sir. Yes,
And
sir.
in
Yes,
certain cases, you will find that your digital instruments are having quantization error because it is a discrete kind of measurement.
yes, sir. They're not
Understanding what
set
I'm
at a
saying?
particular value. They fluctuates
Yeah,
continuously.
yeah. It only represents a range.
Range
So
only.
there are many pros and cons of every technology, but everything does not converge to the accuracy only. So accuracy is altogether is a different domain. So if you are talking about the accuracy, then accordingly you have to find out. So it is
Yes.
not technology dependent. एक डिजिटल इंस्ट्रूमेंट भी बहुत एक्यूरेट हो सकता है भाई, एडीसी हमने बहुत बहुत हाई रेजोल्यूशन का लगा दिया,
Yes.
और और एक एनालॉग इंस्ट्रूमेंट कम आपने सस्ता वाला एनालॉग इंस्ट्रूमेंट खरीद लिया, तो जाहिर सी बात है वो उसकी एक्यूरेसी कम होगी।
ये भी है सर।
ठीक है, तो टेक्नोलॉजी की अपनी लिमिटेशंस होती है, बट always we should be specific that which particular parameter we want to. You cannot generalize कि analog ऐसा होता है, digital ऐसा होता है.
सही बात
फ्रॉम
है।
एक्यूरेसी पॉइंट ऑफ व्यू, जो जैसा है वो तो आपको समझ में आ ही रहा है कि
हम्म
डिजिटल इंस्ट्रूमेंट की अपनी एक एडवांटेज होती है, इट इज यूजर फ्रेंडली, दैट्स व्हाई इट इज मोर पॉपुलर नाउअडेज। ठीक है।
यस सर।
So anyway, you will discuss, you will acquire the knowledge, and then many things you will be able to understand more, whatever questions. But in any case, as far as this numerical problem and topic is concerned, which we are discussing right now, if you people are having any query, you can ask, please. Now, anyway, if you are not having any query, then I'm asking one question that if we are talking about the voltmeter-ammeter method, and this is the simplest method of measurement and its uh, limitations that we had discussed, even with all its limitation, if this method is catering your accuracy requirement, then we will stick to it because it is having an advantage of very simple method, because your ammeter and voltmeter everywhere it is available, and power supply and these things are everywhere available, and the instrument which you are using, they are very cheap also, they are not costly. So from many ways this method is good, but it is having its own limitation, and if those limitations are not satisfying your accuracy requirement, then we'll go ahead with the voltmeter-ammeter method. Now I'm questioning one thing, that if we want to, we within the method we tried two circuits, so that whatever one circuit is having whatever problem, we can get rid of it by having another circuit, and vice versa. Now I'm asking one question, that beyond the method, if you want to handle, you want to improve the performance of this method, then what modification will you make? अभी तक तो हम वोल्टमीटर अमीटर के मेथड के अंदर ही, अगर आपको अब मतलब आपको वोल्टमीटर अमीटर मेथड मतलब इस मेथड को ही सर्किट को ही मॉडिफाई करना है, and now we want to improve whatever shortcomings this method is having. So first of all, you should aware of what is the cause of the problem in this circuit, and how will it be taken care of. तो वो मॉडिफिकेशन हम पूछना चाहते हैं आपसे। आप सोचिए, तब से मैं आपकी अटेंडेंस लेता हूं। प्रॉब्लम क्या है इस सर्किट में, and obviously whatever, if you are able to identify the problem, then you can tell the solution, and that will be basically the another method you can say.
सर अमीटर एक्स्ट्रा
बोलिए।
करंट ड्रॉ कर लेता है तो उसके साथ कोई शंट लगा देंगे पैरेलल में।
तो क्या करेगा वो, उसकी रेंज बढ़ जाएगी शंट लगा देंगे तो,
यस सर।
लेकिन वो करंट तो उसमें रहेगा ही। या इसमें क्या करेंगे
सर लेकिन मेन करंट तो शंट से होके पार हो जाएगा और मिल जाएगा
हाँ?
सर मेन करंट तो
आपको
शंट से
आपको अगर आपको ये मालूम हो जाएगा कि कितना करंट आपको, भाई आप तो यही कह रहे हैं ना कि अगर अगर मेन करंट शंट से चला जाएगा तो फिर तो वोल्ट अमीटर रीडिंग ही नहीं आएगी, then your result will have more inaccuracy. हम तो ये चाह रहे हैं कि जो करंट थ्रू अननोन रेजिस्टेंस जा रहा है वही रीडिंग दे हमको, मतलब ये वाली करंट की रीडिंग दे, ये वाली।
ओके सर। हाँ ये भी है। हाँ आई विल
यही है,
थिंक।
ये भी नहीं, यही है।
ओके सर लेट मी थिंक।
मतलब आपकी जो अमीटर वोल्टमीटर मेथड will give you correct result only in the case when your voltmeter is giving the reading of the voltage across the unknown resistance, and ammeter is giving the reading of the current through the resistance, unknown resistance. Only then these two, we will take the ratio of these two readings, we will get the correct result. But in both the configurations of the circuit, one of the meter is giving good correct desired reading, and another is having some additional added parameter, like in this case your voltmeter reading is not correct, and in this case your ammeter reading is not correct. So how should we tackle this so that we can have a whatever problem we are having in this circuit, we can take care of that. Think about that. I'm coming back. Roll number 1.
Present, sir.
Roll number is same question, is whatever I asked. I'm still waiting for the response. That how will you modify this circuit so that whatever problem this circuit is having, that can be taken care of. G.
सर कुछ
देखो
रेजिस्टेंस
हमको प्रॉब्लम बता दें.
आज
प्रॉब्लम हम आपको कई बार बता चुके हैं. प्रॉब्लम ये है कि यहाँ 2 इंस्ट्रूमेंट यूज किए जा रहे हैं.
यस सर, अब मैं बोल रहा था सर कि कुछ रेजिस्टेंस ऐड कर सकते हैं क्या?
एडिशन के बाद अलावा आप रिमूवल की बात सोचिए तो दैट विल बी मोर रिलेवेंट. अगर किसी तरह से एक ही इंस्ट्रूमेंट से अगर हम रेजिस्टेंस मेजर कर लें, देन दिस प्रॉब्लम वी वोंट हैव. एग्री करते हैं कि नहीं करते?
यस सर, यस सर, अमीटर हट सकता है
की
सर,
वजह से
अमीटर हट
है
सकता
ना?
है, अमीटर हट सकता है सर.
नहीं, अमीटर ही रहेगा. So
अमीटर
this anyway, whatever I'm not saying that you will be able to give. So if we are reducing means from 2 instrument to 1 instrument, then this is the basis of your next method, that is called substitution method. So this is substitution method. Here you can see that it is a 2-step process method. Here you can see that we are using only ammeter here. We are not using voltmeter. So obviously whatever issue that was present in this method, it won't be there. So substitution method is considered as is better than that of your voltmeter-ammeter method in any sense. Even if we are talking about the instrument error also. So obviously if we are using more instruments, and then there will be more error. And here we are instead of 2 instruments, we are using 1 instrument. So the instrument error will also get reduced. And then we are not having that issue that your voltmeter reading is not correct, your ammeter reading is not correct. In the previous case, that kind of issue will not be present at all here. So method is very simple. Here in this case, this is a very simple circuit. You can see that in this case we are using a standard resistance. Standard resistance, its value is very accurately known, and its standard resistance are very costly also. Means what is the value of this resistance to the very accurately. And then this is your unknown resistance. So what we do, we connect this switch. This is your switch to unknown resistance, and then we note down the current here, and then we connect it to the standard resistance, and then we adjust the standard resistance. Standard resistance कभी आप लोग ने देखा है?
हाँ सर, फिजिक्स लैब में सर हमें प्रोवाइड किया जाता था रेजिस्टेंस बॉक्स, उसमें स्टैंडर्ड रहता था.
पोस्ट ऑफिस बॉक्स वाला इंस्ट्रूमेंट देखा होगा
आपने?
वो जो स्टोन ब्रिज वगैरह किया होगा, तो उसमें वो जो नॉब्स लगी रहती हैं, उसको एडजस्ट करते हैं. तो दैट इज बेसिकली अ स्टैंडर्ड रेजिस्टेंस. इट इज वेरी कॉस्टली, है ना. इफ यू गो टू द मार्केट, बिकॉज रेजिस्टेंस यू परचेज फ्रॉम द मार्केट, जनरल रेजिस्टेंस आर वेरी चीप, है ना, कार्बन रेजिस्टेंसेस एंड ऑल. लेकिन जब आप स्टैंडर्ड रेजिस्टेंस बॉक्स लेने जाएंगे तो वो बहुत महंगा मिलता है उसके कंपैरिजन में. तो फिर हम क्या करते हैं कि इसको एडजस्ट करते हैं, and we try to adjust means we try to make it that value on which your current, you get the same current here, because this is a variable standard resistance. So first of all, we connect the circuit to the unknown resistance, and then we note out the current. Then we switch over to the standard resistance. Then we vary the standard resistance to make the current equal, same amount of current. So then we note down this resistance value. So two readings we are taking. One is the ammeter reading when it is connected to the unknown resistance. Then we are switching to the standard resistance. Now we vary the standard resistance so that we should get the same value of the current whatever we were having when it was connected, circuit was connected to unknown resistance. And then when this is achieved with the standard resistance, we note down the value of the standard resistance. So I had discussed all these things, why I'm telling. So obviously R will be equal to S. R will be equal to S. So this is how we basically measure the unknown resistance in terms of standard resistance. This is obvious. I mean, you maybe it is not a magic. It is very simple. When we are connecting this with the unknown resistance, then your equation will be R plus R. ये जो है ये KVL हम लिखेंगे इसमें, तो ये आएगा और दिस विल बी इक्वल टू अप्लाइड वोल्टेज. ऑब्वियसली ये अप्लाइड वोल्टेज के बराबर होगा. और जब हमने स्टैंडर्ड रेजिस्टेंस से किया तब भी ये भी अप्लाइड वोल्टेज के बराबर होगा, सेम करंट. सो इट विल बी इन दिस केस R प्लस S. तो I कैंसिल हो गया, VV कैंसिल हो गया. सो R इज इक्वल टू S. Is it fine to all of you?
Yes, sir.
This is the method. अब आप अगर इसको कंपेयर कर रहे हैं पिछले मेथड से, then what is your comment? Yes, I ask all of you if you are able to understand both the methods, voltmeter-ammeter method and substitution method. Now I ask your comments. What do you means? What is your comment?
सर चांसेस ऑफ एरर यहाँ पर बहुत कम हो जाएगा सर.
तो इंस्ट्रूमेंट के एरर कम हो जाएगा.
नहीं, चांसेस ऑफ एरर की बात नहीं है. चांसेस ऑफ एरर की बात नहीं है. Whatever the voltmeter-ammeter method was having whatever issue because of which we are getting error in the result, that is not present at all here.
Yes sir.
है ना?
Yes sir. That's what you are.
और क्या चीज, हाँ और क्या चीज. अब इसका एडवांटेज, इसका कोई डिसएडवांटेज भी है इफ यू कंपेयर विद द voltmeter-ammeter method.
सो अगर स्टैंडर्ड वैल्यू उतनी में अवेलेबल नहीं हुई सर तो एक्यूरेटली मेजर नहीं कर पाएंगे उसे. क्योंकि सर रेजिस्टेंस बॉक्स
एक रिक्वायरमेंट है इसकी. सब्स्टिट्यूशन मेथड की एक एडिशनल रिक्वायरमेंट ये है कि आपको स्टैंडर्ड रेजिस्टेंस चाहिए. और ये स्टैंडर्ड रेजिस्टेंस ऐसे ही नहीं चाहिए. ये स्टैंडर्ड रेजिस्टेंस आपको चाहिए उसी रेंज का जिस रेंज का आपका अननोन रेजिस्टेंस है. बात समझ में आ रही है?
यस सर.
है ना? तो ये स्टैंडर्ड रेजिस्टेंस, इसमें रिसोर्स ज्यादा चाहिए आपको. ये मेथड जो है उससे अच्छा तो है, ऑब्वियसली उससे अच्छा है, लेकिन इसमें जो रिक्वायरमेंट है वो एडिशनल रिसोर्स की रिक्वायरमेंट है, एंड दैट इज स्टैंडर्ड रेजिस्टेंस. बात समझ में आ गई?
सर ये कॉस्ट क्लियर हो जाएगा तब.
अब इस मेथड के अंदर कोई प्रॉब्लम है, कोई इशू है?
सर और कोई इशू?
इस मेथड, हाँ और कोई इस मेथड का भी कोई इशू होगा. ऐसा थोड़ी ना है कि ये एकदम परफेक्ट है. सोचिए कि मैं एक अटेंडेंस और ले लेता हूँ.
सर रेगुलेटिंग रेजिस्टेंस का इशू. सर रेगुलेटिंग रेजिस्टेंस का इशू सर वो डायनामिक
रेजिस्टेंस है, इसको हम इसलिए यूज करते हैं. ये रेजिस्टेंस हम इसको, ये इसका कोई बहुत बड़ा फंक्शन नहीं है. इसको हम इसलिए यूज करते हैं, जो भी इसकी सेटिंग होगी दैट विल बी सेम फॉर बोथ द रीडिंग्स. मींस जब आप यहाँ एक्सपेरिमेंट कर रहे हैं, यहाँ कर रहे हैं. ओनली थिंग इज दैट कि आपने कभी ये रेजिस्टेंस लगाया और ये जो अमीटर है ये आउट ऑफ रेंज जाने लगा, तो हम क्या करते हैं, इसको वो करके इसको कर लेते हैं कि ये मतलब रीडिंग विद इन रेंज रहे. बस इतना इसका है. हम करंट लिमिटिंग रेजिस्टेंस इसको कहते हैं, है ना? इसका और कोई वो नहीं है. तो इस लेकिन बस ओनली थिंग इज दैट कि इट्स वैल्यू शुड बी कांस्टेंट फॉर बोथ द reading when we are experimenting with R and when we are experimenting with S. In both the
Okay.
cases, so as I told you, it is a two-step process. It is a two-step experiment. तो जो भी रीडिंग है इसकी जो भी सेटिंग है दैट शुड बी सेम, और ये सिर्फ इसलिए लगाया गया है कि ये अगर आउट ऑफ रेंज हो तो इसको हम सही कर दें. ठीक है, बात समझ में आए?
यस.
देखिए इसकी बस एक प्रॉब्लम है कि व्हेन वी आर टेकिंग बोथ द रीडिंग, योर एक्साइटेशन शुड नॉट वेरी. Excitation variation is a big issue, not only in this method, in all the methods. Wherever we are using excitation, in measurement especially, I'm talking about measurement. In measurement circuits, if you are using excitation and excitation is not constant, it creates a lot of problem. So this is a challenge in substitution method, that your excitation should not vary. आपके पहला जो मेथड था उसमें भी आप, क्योंकि आपको साइमल्टेनियसली रीडिंग ले रहे हैं, इसलिए दैट इज नॉट एन बिग इशू, बट हियर इट इज अ बिग इशू बिकॉज इट इज अ टू स्टेप प्रोसेस. बात समझ में आई?
Yes,
अगर ये चेंज हो गया एक्साइटेशन, सो दिस विल नॉट बी इक्वल टू दिस विल नॉट बी करेक्ट. So this is the limitation of your substitution method. So we'll discuss more about substitution method on the next turn. So I'm closing my discussion here. On the next turn, on Monday, most probably on Tuesday, we'll start our discussion from here. Okay. Now you
Sir,
remaining people.
sir, you did not mark my attendance.
हाँ बोलिए, क्या कह रहे हैं?
Sir, roll number 7 mark नहीं किया शायद आपने.
I'm coming to that. I'm
Attendance.
coming to that.
Okay.
I'm coming to that.